Uh-huh. So today we would like to see this coding problem of Caesar cipher, and for this problem a string and a key would be given, and the answer would be, say for example, for this is the question: z by x comma 2. This is the key, and this is the key number of mm, each character will be shifted by this key times. So we have the English alphabets with 26 characters, isn't it? So from if A to Z, it go back to A again. Say if Z is present, it will go back to A and will count from the shifting from there. So Z, A, B, that is two shift. Y, X, Y, Z, and again A, this is two shift. X, Y, Z, this is two shift. So that is the problem. This has to be programmatically solved as usual. So we will start with uh, theoretical analysis, time and space complexities, and actual implementation part. I will use Python for the implementation. Okay, so so how to approach this problem? So this being a string problem, so in actually in Python or any language, there will be already a alphabet number mappings that is called Unicode characters. Say say for A, small a in English alphabet A, there is mapping of 97. In Python, we get this value by calling a function called ordinal. And if we just pass this, so we will get 97. And similarly, z, small z, is 122. Just this 20, 97 plus 27. 97 plus 20, 25, right? This. So 97th is a character and later 25 characters are there. 25 alphabets. So yeah, 122. So Z is 122, small z. So these are small a, small z, and the problem states that only the small letters, small characters will be given. Yeah, lowercase letters will be given. That is need to be z by a, z by x. Okay. So okay, using this odd function will actually, as I told, just uh, convert the character to its Unicode value. Similarly, there is a function called char, which will take the number and will convert into mm, the character. So it's on both sides. So we need to, what's the logic that we can implement here? Take one character, add some, get the Unicode value of that, add the key value, and convert again it into character, and just join those obtained characters. Okay, so so we will see a little bit logic more. How can we do this? So we will iterate through this input given string, and say for on character. So the one important thing here is we have the A to Z, and as it saw, 97 is A and 122 is Z. There are little bit edge cases that need to be considered while doing this. That is, say if we have added uh, the ordinal character, so say we have got the Z, and we calculated the char, which would give 97 for the given character. Char is z, and I'm trying to add the key, which is 2 here. If this crosses the 122, say it crosses to the 122, say this is 122 plus 2 is 124. This 124 has different character here in Unicode, but that is not we want. So we need to convert again this value back to this number again to the between 97 and 122. So how can we do that is using modulus. Okay, so this is the condition. So if the number update, say I will call this as number, some number, the new number 124, and I want to convert it in between 97 and 122. If this number is less than or equal to 122, then no issues. So just return the character of the actual character of that number. But if that is not the case, we need to do something like return character of number, but the modified number. So this is 97. So what I'm going to take here is the previous one, like 0th index you can think of, that is 96 plus this number modulus. I need to keep this within this range, so 122. So what this will give is, if you keep 124 here, 124 modulus 122 is 2. So 96 is nothing here in this. There is nothing. 96 character is available in the English alphabets, but we are not bothered about that. 96 plus 2, which gives 96. So 98. 98. What is 98? 98 is B. So that is what. So G is converted to B. So this is the one thing that we can use. But one more thing here is, we need to, there is one more edge case here. There is a number we are getting here. Say we got this number, a large number. Currently we got 124, but sometimes if you get 120, 140 or something, 140, just I'm randomly assuming. So that will create some out of bound index or something out of the character. So how will it create is 140 modulus 122 is 18. 96 plus 18 is 14. 9, 10, 11. 140. So there's no problem for this one. I will take a little bit bigger number. 120, 150 plus 150 modulus 122, which gives 4, 28. 28 added to 96. I'm doing this calculation. 124, yeah, it crosses to the 124. So finally, if you get here 124, there's nothing. We already crossed to the 122 limit. So to avoid that, so what is the reason that we crossed to the 122 here? Because this number is greater, larger. Then, so what's the thing that is causing here bigger value is the key. If you get more larger key, like we got here 2. So if you get something larger, 22, or an integers of just 26 plus 26 plus 2, 14. If you get key as 54, we will get key as 54. So in that case, what will happen? This is actually sum of 26, 26 and 2. So 26 is itself rotating itself, need to rotate itself. 26 again need to rotate itself. So in that case, we need to just modify this key and update the key percentage this 26, because 26 characters are there, 26 alphabets are there. So just keeping this will not create this problem of going out of 122. Okay, I think this is, yeah, this is fine. So this is the major logic for doing this. So just we need to um, make this into a list and um, make this into a list and apply this each character and finally join. Okay, so what are the time and space complexities for this? So time, we are just iterating once through the given array, and we are not concatenating a string here. We are going to just join like this. Dot join and pass a triple like list. So this is executing in, this will execute in constant time. So time complexity for this is big O of n, where n is the input length of the input string, and space complexity, are we building anything here? So yeah, we might be building that list, the new list. So it is big O of n, which is equal to say this length. Okay, so we can go for implementation part. So def, I will call Caesar cipher. Caesar cipher, which takes a list of two parameters. That is, one is the input string and key. Okay, so what need to be done? So the first part is converting it to a list. So that can be done by doing like for I in range length of input, iterate through the length of the input, and I will create a new list, a list name that is characters list. Characters is equal to empty list, and I will append characters. So what can I do is characters append, just append the converted value directly instead of we can just convert this. I will create a new helper function like get converted value, get converted character, get converted character, which takes input as, which needs the input of this input, and we will see what else is needed. So we will create that helper class definition that get converted char. So get converted char, in this function this logic goes. So need to create that number, whatever number is equal to the character of given char, because we are iterating, this character has to be sent here, maybe as a list, because we can just um, send the characters, get characters. So we can send like this: input input of I, that is one character, and the key value, isn't it? I haven't, because we need to calculate this new key, right? So new key is equal to key is percentage 26 modulo 26. This is new key, and there are two characters are getting passed for this new function. That is character, that is one letter actually, one letter. So on the new key. Okay, so here what we're doing, we're just checking number is equal to calling this char function of Python, character of Python. Okay, this will create a number, actual number, and we need to check if this number is less than or equal to this 122. If it is less, return directly the, okay, so oh, I think I have written a little bit wrong. This is odd. This is odd of character. This is odd of character. So ordinal will give the actual number. Character will convert back a number into the character. So here we got the number and we found that it is less than or equal to 122. Then we can just convert back it into character and return it. If that is not the case, so just return character 96. 96 is the previous one. 96 plus number, the calculated number, modulo 122. Okay, so this will give you a new character by taking the new key on this. Okay, so and finally this characters list will contain the converted characters in a list. Need to append, need to concatenate actually, need to concatenate like this. So just so characters, this will create the characters. I think that's it regarding this implementation. So just create this new character list and new key that we talked why we have taken, that is so to avoid going out of this 122. So we are trying to get the percentage, I mean modulo 26, and iterating through the input array characters.append and calling a just helper function, and again joining those into this. Okay, so this part is completed using this implementation. But okay, if we don't want to use this odd or char, because there might be some cases where these characters value, these formulation, these characters, these numbers exact is not remembered, or don't want to use that, or some new alphabet, it's not all English alphabet, because we just knew about the English alphabets, that okay, for this lowercase English alphabet this is the mapping. But if you got some Greek alphabets, so in that case, so we need to create our own mappings For making that, so what can we do is we just need to create a new. In that case, if you don't want to use the this char or odd, we can create something like a list. We need to make our own mappings. So this has to be the part that's come here. I'm going to write here. So I'm going to just create an alphabet list. Alphabets, say alphabets. It may be any alphabets, but in this case it is still this English alphabets. I'm just passing a string, a 26 character string of English alphabets, because we are talking about the lowercase letters, just A B C D E F G H I J K L M N O P Q R S T U V W X Y G. This is a single string of 26 characters, and it need to be passed here, so we can get the ordinal value here. What's that? So if you want to get the odd character, we can just call what will odd do? It will take the character and will convert into its index, its value. So for this we can just pass this, say for example, a character, and we can get the index. By getting the index, it is just a value mapping. So instead of odd, we don't want to use odd, we need to call something as getting um, alphabets. I'm just calling the index function just to get the index of that character. This will give the number. No. And for this, what has to be passed here? Alphabets has to be passed as a new parameter. Just this newly created alphabets. Alphabets to this helper function. Okay, so we got the number. We will use the number here. So in this case, do we need to make any big changes? New character. We are just still for the new, like using this, still the 26 alphabets would be there. Still 26. It won't change. Right? Okay, so new key alphabets. Alphabets passed. Yeah, the one more change here has to be done is this 96 is when we are going to use the odd. But what is 96? 96 is just one number less than the a in the mapping of the Unicode mappings. But we are creating our own mapping, so the mapping for the a currently here is 0. So need to put -1, and this not gonna be anymore 122. What is 122? 122 is the mapping for the G in the Unicode actual mappings, but here it need to be 25. This indexes is from 0 to 25, so 26 characters. So that is one change, and we are not going to uh, call the char function anymore. Just this will create an index, say for example 2. Just call the alphabets. Just call the alphabets like an index. Just calling an index of it. Okay, so Okay, so we have this string and we can call this. What we are doing in this new our self mappings, we just created the alphabets, a list, creating the giving actually the string of alphabet characters, the lowercase letters in this case, and we are just iterating through the given input. Still we are inputting, we are iterating through the input and appending, calling a helper function which takes this input value, each character, new key is this, and alphabets, passing the alphabets for calculating the character, and mm, this. Okay, I think that's it. So this completes, this executes in big O of n time, and we are just creating new alphabet, this one. So it is big O of n space complexity 2. Okay, that's it.